Hello friends, this is Deepak Kumar, Assistant Professor in Kite Group of Institution, Ghaziabad. In this lecture, we will discuss the concept of pin diagram of 8085 microprocessor. So, we are just moving towards the pin diagram of 8085 microprocessor. So, actually 8085 microprocessor, if we are talking about the pin diagram, so it basically contains total 40 pins. Out of these 40 pins, as we know that 8085 microprocessor basically contains 16 bits address line. So if we want to represent these 16-bit address line, so 16 pins are actually required. So here from pin 12 to point 19 and pin 21 to pin 28, these particular pins are basically used for address line. As we also know that the address line is basically divided into two halves, lower half and upper half. So lower half 8 bits are basically multiplexed. That means for a particular time it will contain the address information, and for some another time it will contain the data information. So these 8 pins are basically utilized to contain address as well as the data information. So here the data information is also stored in these 8 particular lower half address pin. So that's why it is represented as 80 to 87. So due to this multiplexing, the number of pins in 8085 has been reduced. If you are moving towards another pin, so actually these pins are basically contain the interrupt signals. So trap, RST 7.5, RST 6.5, 5.5, INTR, all these are basically the interrupt control pins. Okay. Out of these pins, the trap is very high priority interrupt. That means if this type of interrupt is available, then there is no another way of 8085 microprocessor. It must have to handle this particular interrupt. This RST 7.5, 6.5 and 5.5 is generally maskable vectored interrupt. That means here the program control basically takes the control of the program to some other locations. And then we have INTR, that is interrupt request signal. So that is very low in priority. So these are basically your interrupt pins. INTA complement. What does it mean? It means that this is your active low signals. Active low signal means what? That means when the value of this is 0, then this becomes active, and when the value of this particular pin is 1, then this becomes low signal. Okay. So that is actually the meaning of complement. When this is 0, then it is active. When this is 1, then this is deactive. Okay. So this interrupt acknowledgement is basically sent by this 8085 microprocessor to other devices that right now it is basically handle a particular interrupt. So that interrupt is basically acknowledged. So this signal is basically sent via this particular pin. That is your interrupt acknowledgement. SID, SOD, as the name suggests, that is serial input data and serial output data. So whenever microprocessor want to access the information, that means want to read the information from peripheral devices, then it basically takes serial input data with the help of this pin when this is high, and when this pin is high, that is serial output data, then the microprocessor basically provides serial data to the peripheral devices. X1, X2, these two pins are basically used to manage the internal clock frequency of 8085 microprocessor. So as we know that 8085 is operate in 3 megahertz clock frequencies. I just told you in our previous video, that is 8085 internal architecture, where I told you that 8085 basically operates in 3 megahertz frequencies. So with the help of these two pins, that is pin 1 and pin 2, we maintain these clock frequencies, internal clock frequencies for this 8085 microprocessor. This clock frequencies is basically made with the help of RC and RL connections. On the basis of that, this 3 megahertz clock frequencies has been maintained. VSS and VCC. These are basically, VSS is basically used for ground signal, and VCC is basically used for plus 5 volt power supply. As I earlier told you that this is your digital processor, so that actually operates with some power. So plus 5 volt power supply is required. So with the help of this VCC signal, plus 5 volt power supply is provided, and VSS is basically used to provide the ground signal. Okay. Next one is your hold and HLDA. Actually, as I earlier told you that 8085 basically supports DMA. So in DMA, some external devices want to access the address as well as the data bus information of this 8085. So for this purpose, that devices will request to 8085 to please release your control and please provide me the access of address and data bus. So for that request, this hold signal will be sent. So this request will be provided via this particular pin, and when this DMA request will be accessed by 8085, then this DMA will send the acknowledgement signal via this particular pin. In the same way, we have clock out. Clock out pin is basically used to generate the clock pulse for peripheral devices, or it is basically used to configure the peripheral devices, configure the clock pulse of peripheral devices. So for this purpose, we generally use this clock out pin. Reset in is basically used to reset the microprocessor. What do you mean by reset the microprocessor? When this is basically active, that means actually here we have complement, so this is your active low signal. So when this is 0, then this pin is active. So when this pin is active, that means that the program counter content will be 0. Okay, as we know that the content is basically represented in the form of hexadecimal representation. So this is basically your 16 bits information in hexadecimal format. Okay, that is represented by these 4 zeros. So the program counter content will become 0. That means this 8085 has been reset. And in the same way, we have reset out signal. It basically provides the information to the peripheral devices that right now 8085 has been reset, as well as this reset out signal will reset some peripheral devices also. So that is actually the meaning of this particular pin, that is reset out. The next one is your ready pin. Actually, when microprocessors are communicating with peripheral devices, then the speed of microprocessor is very fast in comparison to peripheral devices sometimes. So to manage this speed mismatch, this ready signal will be activated so that the information is properly transferred to the peripheral devices. That means it basically instruct the 8085 microprocessors that please wait for some time so that the information has been retrieved by the peripheral devices. This S1, S0 and this address latch enable, these are basically your status pin. With the help of these 2 pins, we just identify that either we just want to perform memory read or input output read on operations. So these are basically the status signals. Address latch enable, that is ALE. This pin is activated. ALE is basically used to multiplex the lower half 8 bits of address line. Okay, as we know that the lower half 8 bits, that is A7 to A0, that will be considered as multiplexed address line where the address as well as the data information has been saved. So that's why these pins are basically represented as AD7 to AD0. So how can we identify that this 8 bits information contains the address information or the data information, because I earlier told you that at the same time it doesn't contain both the information, that means address information as well as data information. For some particular time that 8 bits will be considered as an address bits, and for some another time that 8 bits will be considered as a data bit. So how we can identify that this is your address bits or data bit? So this will be identified with the help of this ALE bit. Okay, if it is 1 or if it is 0, so for some time it will contain the address, and for another value it will contain the data information. So that is the role of this ALE. Read and write control signal, as the name suggests, it is basically used to perform read operation, and it is basically used to perform write operation. Okay, read means take the information from the peripheral devices. If we are talking about main memory and we want to access the information, that means when the information is taken from the main memory, then it is read operation. When the information is provided to main memory, then it is your write operation. So, and these two pins are basically your active low pin, because here we have complement. So when this is 0, then it will be active. When this value is 0, then it will be active. When it is 1, then it is deactive, and it is also deactive. Okay, so that is the meaning of active low signal. Input output oblique memory complement, it will tells that let's suppose if we want to perform read operation, so from where we want to read operations, from memory or from peripheral devices. So that discrimination is provided via this particular pin. That means read and write operation is performed towards the memory or the input output devices. Okay, so that is actually the meaning of this. I think I have covered all the particular pin of this 8085 microprocessor. So these are actually the meaning of the pin value of 8085 microprocessor. These are the references for this particular lecture. So this is all about for this lecture. Till then, thank you so much.